So let me welcome here our another guest, another keynote speaker, now from Adam Mickiewicz University, Paweł Łupkowski with his speech on the topic logic of questions in the wild, inferential erotetic logic in information seeking trial modeling. So please.
Yeah, thank you. So hello, I'm from Institute of Psychology, but I will speak about logic, but logic in the wild. So I'll take you with logic to the strangest place when you can see logic in its non-natural behavior. I will be interested in modeling of natural dialogues, so natural language dialogues. Especially I will be interested in the phenomenon of question processing. So if you think about about discourse in general, you have this phenomenon of question processing, which is a situation when a question is not followed by an answer, but by another question, basically. So this is the most general stuff. So the idea is that the new question or a strategy, it is replaced by a new question or a strategy of reducing it into a set of auxiliary questions. So the idea is that usually you will observe such a situation when an agent wants to solve a certain problem, which might be expressed as an initial question, and then afterwards he or she is not able to reach a solution using its own information resource, and that's why we need a new data collection, and we collect this new data by asking auxiliary questions. So, like in this example taken from the basic electricity and electronic corpus, which is corpus of tutoring in electronics, you can observe this. So first we have a tutor, he asks a question. So, but if they are moving in the same speed, will anyone actually ever run into another else? And then a student reveals certain part of the information he or she has, and then she asks a question because she's not able to produce an answer to this initial question. So she asks a question, auxiliary question, which will allow to collect additional information. So instead of an answer, we get another question. Here we have another distinctive solution of such a behavior, which is produced by one and the same agent. Namely, it's taken from British National Corpus, and we have a question. Agent A asks, okay, for anybody who's interested in eating, pâte foie gras is made from what? And there is no answer. So what the agent A has to do is she has to rephrase the question in order to make it more viable or easier to answer. So it is processed and changed, and she says, right, we'll be even more specific, right, as a help for you. It's made, this pâte foie gras is made from the liver of what? So this is the rephrased question. So I'll be interested in such behaviors in language. To model these behaviors, those events, I will use inferential erotetic logic. This is my framework of choice. It was introduced by Wiśniewski. Why? Because it's a quite natural choice if you think about question processing. So IEL focuses on inferences whose premises and conclusions are questions. These are so-called erotetic inferences. So this is quite a natural choice if you'd like to think about question processing. And there are several motivational factors for the choice of this logic. IEL is flexible, so it is not tied up to any specific logic of declaratives. I will explain it in details in a second. The formal representation of questions is friendly to the user. It's very simple to grasp the idea behind representation of questions in this logic. And IEL offers, this is the most important part, it offers very straightforward tools for modeling erotetic inferences, and it offers a criteria of validity of those inferences, which is very important from my point of view. Of course, you may ask a question which will be a good question. How might logic be used to study natural language dialogues? And how will normative, because the logic will offer you normative perspective, and descriptive perspective will be merged together. Of course, I should explain the title, why it is logic in the wild, logic of questions in the wild. It was inspired by a book by Stenning and Lambalhen, Human Reasoning and Cognitive Science. There is a chapter 5 entitled From the Laboratory to the Wild and Back Again. And this is the inspiration for the title and for the whole approach. They claim very convincingly that if you think about reasoning and logic, logic provides a very useful normative yardstick to study, describe, and analyze this phenomena. So yeah, I got very convinced by this idea. And of course, such an approach, if you take this approach, which is proposed there, opens new perspective as well for logical and also for empirical research, as it is claimed in paper by Urbański. So if you think about this cognitive turn in logic, it appears that logic might be and is successfully applied within the research concerning actual human reasoning. There are some, for example, those papers review some examples. These are the examples from 2015, for example. So yeah, I think that it's quite a good idea to try to use this approach to apply logic to a real phenomena. But of course, we should make some restrictions. So of course, I do not claim that logic concepts are the ultimate explanation of linguistic phenomena. I don't claim that anyone in this room is reasoning according to IEL. This would be not a good claim. Maybe I do, but what I claim is that IEL offers convenient tools for modeling natural language phenomena and for their better understanding. And what I will research, it is I will use this tool for tools as the issue of with the issue of motivation for certain dialogue moves. So I will be wondering what might be the reason behind a certain choices of dialogue moves made by dialogue participants. And as such, I will use IEL exactly. So this is logic of questions in the wild, but we should start with the logic itself for the first time. So steady as it goes, logic. So we take a language and we will enrich this language with questions. So we are doing this according to special recipe, which is called minimal erotetic semantics. This is one of the advantages of this approach. You can define logic of questions on the basis of logic declaratives, provided that this formal language allows for partitioning declarative formulas into true and untrue ones. So for our purposes, we just use CPL, classical proposition logic, but you can take any logic which is rich enough that allows you to divide your formulas into true and untrue ones. So in what follows, I will use capital Qs for metalinguistic variables for questions, A, B, C, D as a metalinguistic variables for declarative formulas, X, Y, and Z for sets, and this bold D, Q as a set of direct answers to a question Q. Okay, so we start with simple classical propositional logic. So it contains primitive connectives. The concept of well-formed formula is defined traditionally. We'll use P, Q, R, S as a propositional variables. And evaluation is understood classically, so nothing interesting happens to this point. What we do now, we introduce the object level language with the question mark. So we'll add certain symbols, signs, question mark, and brackets, and the comma, which allows us to represent questions in this language. So now our new language will have two categories, which are declarative formulas and erotetic formulas, which are simply questions. And those categories are disjoint. So if you think about question in this language, it is expression of the form presented here. So you have question mark, brackets, and some declarative formulas. So this is basically general structure for a question. You should have at least two formulas in this set. They should be syntactically distinct, and they are declarative formulas. So if this formula is a question, then each of the declarative formulas inside is called direct answer. It's called direct answer. So as you see, this is a very simple way of representing questions. It boils down to the saying that if you know the answers, you know the question, basically. You can read this structure as a counterpart of natural language question. Is it the case that A1 or is it the case that AN? basically. So that's the idea. This is called sets of answers methodology, and it allows you to work with questions quite naturally. In what follows, I will use two abbreviations. For very simple question, is it the case that A or is it the case that non-A, I will use simple question mark A. And for so-called binary conjunctive questions, which cover all logical space of possible answers, for is it the case that A and B, A and not B, not A and B, not A and not B, I will use this abbreviation question mark plus minus AB. I will remind when it appears again. So now we have a formal language with questions. So we start to think what will happen when I would like to move from one question to another question, when I would like to infer one question from another question, in the same way we do in propositional logic with sentences or declarative formulas. And in IEL, we do this by means of so-called erotetic implication. Erotetic implication. So this erotetic implication allows you to say when it is allowed to move from one question on the basis of declarative premises, possible set of declarative premises, to another question. And it offers a criteria of validity. So it demands two things. So if the initial question is sound, which means that there exists at least one true direct answer to this question, because if you think about question, you cannot just simply think that question is true or false. These are declaratives. But question might be sound, which means that it has at least one true direct answer. And all the declarative premises you use are true. Then the question, which is the conclusion, must be sound. So according to erotetic implication, if you start with a sound question, you will end up with a sound question. And each direct answer to the question, which is the conclusion, should be useful in answering the initial question by narrowing down the space of possibilities offered by the initial question. So the idea is, the intuition is that if you replace the initial question with the implied question, it should bring you closer to the solution. That's the intuition. So we can provide a definition. So a question Q will erotically imply a question Q1 on the basis of the set X of declaratives. This is the way we'll write it down. So Q implies on the basis of X Q1, if and only if for each direct answer A to the question Q, if you take X with the set A, entails disjunction of all the direct answers to the question Q1. This makes the first condition true, the first requirement. So if you start with a safe question, you will end up with the safe question. And the second question, which the second condition which requires this usefulness, is rephrased in the following manner. So for each direct answer B to the question Q1, which is the outcome of erotetic implication, there exists a non-empty proper subset Y of the set of direct answers to the question Q, such that X and B will entail a disjunction of all the elements of Y. So these are the requirements. But the intuition, we should stick with the intuitions. So first we will transmit soundness. So if you start with a sound question, you will end up with a sound question. And this usefulness. So if you have erotetic implication, implied question, which is the outcome, will get you closer to your solution to the initial one. So this is a very simple example. So this is implication of question, is it the case that A on the basis of set A if and only if B, and implied question is it the case that B? So for each direct answer to is it the case that A, it is if it's true and the premise is true, then at least one direct answer to is it the case that B is true, and the required proper subset is also shown. It is very intuitive. So if you ask yourself whether it is the case that A, and you know that it is always A when B, so you can very safely ask about B. I think it's quite intuitive. So this is this condition when you can move from one question to another question on the basis in this logic, when you can infer one question from another question. And if you think about using this implication for decomposing one question, you can imagine that you have initial question, many declarative premises, and you can infer many questions on basis of this setting. So you can imagine that you use erotetic implication many times. So it's easy to imagine that it might be repetitively applied while solving a particular complex problem. So you start with very complex problem, you have some declarative premises, and you arrive to a question which is erotically implied, and then you take this new question and also decompose it into a simple question. And you do this as long as you can, as logic allows you. And this is captured by the idea of erotetic decomposition principle, which says transform a principal question into auxiliary questions in such a way that consecutive auxiliary questions are dependent upon the previous questions and possibly answers to previous auxiliary questions. And once auxiliary questions are resolved, the principal question is resolved as well. So this is the intuition, is that you start with a complex problem, you decompose it into a set of simple problems as long as you will get the solution to the initial one. So this is basically what many of us do when solving problems. And this idea of repetitive use of erotetic implication for this purpose is grasped under the notion of erotetic search scenario. And the erotetic search scenario, I will present it as a set of so-called erotetic derivations. So we have to introduce the notion of erotetic derivation first. So the intuition is that erotetic derivation is a sequence which leads you from the initial question through auxiliary questions and answers to those auxiliary questions to the solution to the initial question. So this is very easy to imagine how it might work. So erotetic derivation will be a finite sequence of well-formed formulas of either direct answer A to a question Q on the basis of set X, if the first element of this sequence is initial question and the last element is answer to the initial question. And if you meet a question in this sequence, it is different from initial question, and it should be implied by a certain erotically implied by a certain question which is before this question you've met. And the next element after of the sequence after this question should be a direct answer to this auxiliary question or another question simply. So this is the structure. I think that we'll get more intuitions when we take all of those derivations together. So we make a family of those derivations, and then you get this structure which is called erotetic search scenario. The name is very informative because it's basically a scenario of all possible ways the questioning might go. So the pragmatic intuition behind this scenario is that, as Wiśniewski quote says, it provides information about possible ways of solving the problem expressed by its principal question. It shows what additional data should be collected if needed and when they should be collected. What's important, each scenario provides the appropriate instructions for every possible just sufficient. So the direct answer to a query, and there will be no dead ends. So if you think about each scenario, it has a tree-like structure with the main question as the root. So your main question of your research is the root, and direct answers on the leaves. And the other question which appears in the structure are auxiliary. So this is the basic intuition behind the scenario. You start with a question, which is your initial problem. It's usually it's very complex. Then you have some declarative premises, and you use erotetic implication to devise an auxiliary question. And if you'd ask this auxiliary question, you will receive a direct answer to this auxiliary question. And of course, dependingly on the answer you will receive, you can make another step. So, for example, in this case, you received positive answers to this query. So you can devise a new auxiliary question accordingly to erotetic implication, and you ask this second auxiliary question, and again, dependingly on the answer you get, you can make another move. And you do this as long as you can, and namely as long as to the point you will reach the solution to the initial question. So we have each of such paths leading from root to the leaf is called path of any scenario, and each path of a scenario is erotetic derivation. So what is crucial, each auxiliary question appearing in this structure is erotically implied by something which is above. So this is crucial. You cannot introduce random questions in this scenario. They're like goal-directed structures. So it provides you with instructions which question should be asked in which moment, dependingly on the answers you get. So this is very simple scenario written in our formal language introduced before. So here our main question is it the case that P, and declarative premise is P if and only if Q, and we remember that P, is it the case that P and this declarative premise erotically imply the question about Q. So we introduce auxiliary question about Q, and now dependingly on the answers we get, this question might go in two ways. So answer will be Q, then we will know that it is case that P, and if answer will be non-Q, then the answer to the initial question will be non-P. And each path of this scenario, so this is one, the leftmost path and the rightmost path, are the erotetic derivation. So this is the erotetic derivation, starting with initial question, premises, auxiliary questions, answers to these auxiliary questions, and the solution to initial problem. So that's the basic intuition behind those structures. So as you may see, this erotetic implication plays a crucial role and allows you to introduce such a goal-directed structures. So now we have logic, and we may take it for a ride, and we will see how it goes. So we go to the wild. So natural question will be implied by what I said. Okay, you showed us how to do this in logic. It's probably cool. I mean, I see that you were a little bit bored with logic parts, so probably it's cool. Not for all of us, but I assure you it's cool. But then we may say, okay, it's logic. So how does natural language relate to the presented picture? I mean, the picture is nice. You can draw some trees. If you like drawing trees, it's cool. But yeah, is there something in natural language that is similar to what you've shown us? So yeah, there is. Basically, spoilers. So I will present some data from the corpus study about query responses. So the more general category, not very narrow one. So the idea is that we did a corpus study because we wanted to investigate the phenomenon of answering questions with questions. Basically, if you ask a question to someone, you expect an answer, not another question. But apparently, if you take a look on the data, it's very often that you will encounter another question instead of answer. So what we did, we take the basic electricity and electronic corpus, British National Corpus, Child's corpus, and AMEX corpus, and we gather it almost 1,500 query responses pairs, and we try to study the typology of query responses. So query response is the way you react with a question to a question. And on the basis of the collected data, we received the typology. So one of the obvious categories were clarification requests. So this is something you would expect if you think about this. So yeah. The second category was dependent questions, which will be called DP, and dependent questions, namely cases when the answer to the initial question depends on the answer to the question response. So you ask a question, and the reaction is a question. You have to answer before you will reach the solution to the initial one. There were also motivation questions. So question about the underlying motivation behind asking the initial question. So I am asking, are you going to Brno tomorrow? Why are you asking me this question? Of course, there were also reactions which we classified as no answer. So questions aimed at avoiding answering the initial question. So you ask somebody a question, and instead he or she asks another question which is loosely related to the subject. There are also form questions, which are the questions considering the way of answering the initial question should be provided. So, for example, you ask me a question? Will you present whole idea of erotetic implication? And I react, instead of saying yes, I ask you, would you like me to go to each detail? Through each detail, for example. This is the form question. And of course, there are also question answers, so questions with a presupposed answer. So you ask me whether this jacket is new, and I say, I received it last Christmas, what do you think? And there are also ignore questions, which are semantically questions, but are responses which ignores the initial question totally. And it will be no surprise that this is the rich typology. I mean, this was a great news for us, that if you think about query responses, you have rich typology of many different reactions. But it will be no surprise that for this talk, for today, I will be interested mainly in dependent questions. Because these are the dependent questions which simply relate to the idea of question processing. And I will try to convince you that dependency of questions can be efficiently analyzed in terms of erotetic implication. So this is a phenomenon observed in natural language, and I will try to convince you that we can effectively model it with erotetic implication, which is a tool from logic. As from a linguistics approach, we can find a very nice definition of question dependency in Ginsburg. Ginsburg's book, so he writes that Q1 depends on Q2 if and only if any proposition P such that P resolves Q2 also satisfies P entails R such that R is about Q1, basically. So the intuition is that whenever an answer to a question Q2, I mean the one which is given as a response, is reached, then some information, not necessarily all information, but some information about answer to Q1, I mean the initial question, becomes available. So from the dialogue studies perspective, it is said that the dependency of question allows us to say that Q2 is relevant response to Q1, as it's illustrated from, for example, on this example from BNC, British National Corpus. So if A asks, are there any other questions, and you would like to receive an answer, but in spite of this, you get a proper relevant response, which is a question. Are you accepting questions on the statement of faith at this point? So whether more question exists depends on whether you are accepting questions on the statement of faith at this point. So you may see clearly the intuition that you will not get answer to this question as long as you provide an answer to the second one. So it will be necessary to resolve this, and then at least part of information about this answer to the A's question will be available. Yeah. So this is the intuition behind the question dependence. Of course, we may ask, how common are these? Because you probably feel that clarification requests are the most common question response you can get, and that's a good intuition. But how common is dependent questions in the data? So if you think about generally oriented corpora, not a task-oriented corpora like B and C or Childs. So dependent questions are the second largest class among the recognized types of query responses. So the first one is, of course, clarification requests, but they are the second most popular. And if you think about goal-directed dialogues like B and AMEX, so B are tutorials for electronics, and AMEX are information, is a corpus from touristic information, basically. So these are really goal-directed dialogues. And dependent questions in this corpora are the most frequent category of query responses. So if you remove clarification requests from the data, you'll get that dependent questions are second most popular query responses in all the data. So all the others are really not very popular, despite of ignore in Childs, which is quite okay, because Childs is a parent and child conversation, and if you think about speaking with your child, it is often that she or he will ignore your question. That's quite okay. So one lesson from this lecture is it's okay when the child ignores you. It's in the data. It's according to a certain purpose. Okay. Another good news, it is not only the case that the dependent questions are very popular and you can meet them, but you can also automatically recognize them. So what we did, we ran certain tests with automatic classification of clarification requests and dependent questions, and the results are very promising. So we've got not only our classification, our recognition, but also automatic classification which recognize dependent questions, which is a good news. So they're not fake. When we take a closer look on the question dependence in the data, I will choose this dependent questions in the corpus B because it's a corpus of tutorials and it's a good testing field for this. So analyzing these dependent questions in this corpus allows you to have some insights into a question-hood relation, and if you take a closer look on the structure of query responses in this B corpus, you see that the dependent question responses takes 62% of the whole sample. It's even much larger than clarification requests. So as you may see, this is very cooperative dialogue type between tutor and teacher, with the most frequent type of dependent query responses. Of course, we may also ask: is it the case as in IEL, that because in IEL, as you noticed, the assumption is that there are some answers, there are some questions and answers provided. The answers to those questions are always provided. So is it the case with dependent questions that they will behave the same in natural language data? So if you check, if you analyze dependent query responses in terms of leading to a subsequent answers, namely, if you get an answer to Q2, will you get an answer to Q1 also? Because you would like to expect this. It's exactly the case. If you analyze all the data we retrieved from the B, so for all examples of dependent questions, we have that if the answer was provided to the second question, the answer was also provided to the first question. So this is really good news. For AMEX, it's a little bit worse. So it's only 96%, but 96% is also quite high. So all pairs of initial questions and dependent question responses were provided with an answers in B. So it is also another hint that if you think about tutorials, friendly internship of tutors and students, it's good. They like to cooperate. What is more, you can also analyze, if you have this data set of dependent query responses, you can also take a look what type of question are they. Because as you noticed in IEL, in this very simplified version I've presented to you, we consider yes-no questions. And it is also the case that if you think about dependent question responses, yes-no questions are also very popular. What is more, the tendency is that if you start with yes-no questions as a teacher, and a student will respond with a dependent question response, you will also get a yes-no question. So the pattern is that yes-no question lead to yes-no question in the most cases. The most cases. So that is also a good news. So if you try to compare the picture presented with IEL and the picture from the data, so the following pattern of relations between questions and dependent questions in tutorial dialogues appears. So the most frequent category of query responses are dependent questions, which facilitate the search for an answer to the initial question. So this is also a good news. If you think about the type of question used in this context, it is mostly yes-no questions. And if you think about the pattern of from Q1 to Q2, it is if you start with yes-no question, the most probably you will get yes-no question response. And what is also really good news, if both the question and its question response are answered in the all analyzed cases. So it's very nice picture from the natural language data that you can relate to the picture in logic. So apparently it is quite convincing. Of course, with obvious restriction about some restriction in the research, because we didn't analyze all the examples that exist. That's obvious. So now we can take this step and try to use erotetic implication as a tool in analyzing those dialogue moves. So I will try to use erotetic implication to analyze dialogue moves retrieved from the natural language corpora, and try to find or try to argument that you can use this normative tool to seek for a justification for certain dialogue moves. So you will be able, after using this, you will be able to say, okay, this is justified move in a dialogue if you would like to reach your goal in a dialogue. So that will be a role of erotetic implication in this consideration. This is due to the characterization of implications, so erotetic implication. So if you think about those dialogues, when the most frequent type of question response is dependent question response, so they are goal-directed and very cooperative. This is a very important assumption and restriction of my argumentation. Then erotetic implication seems perfect, because if you think about implied question, so implied question will always stay on the main topic, because no random question will appear here because of the characterization of erotetic implication. And the answer provided to the auxiliary question should be at least a partial answer to the initial question. So it will bring us closer to solving our main problem, which is the goal of the goal-directed dialogues. So we can perceive the discussed process of replacing one question with another simple question as a justified step from the problem-solving perspective. If you think about goal-directed dialogues, and you will be able to show that the new auxiliary question is introduced accordingly with the requirements of erotetic implication, you can say it's a justified step. It's a justified step. So this is how I will try to use erotetic implication in this consideration. Okay, so let us do this on certain examples so we can see how it works. So first example is taken from BNC, British National Corpus, and it goes as follows. A says, do you want me to push it around? And B answers, is it really disturbing you? Okay. So we have clearly a dependent question response. We have to solve this issue before we go to solving this issue. Of course, there's one huge problem with corpus data. Corpus data, you have as it is. You will not get any explanations to this corpus data. You are not able to find A and B. You cannot write to guys from British National Corpus and say, okay, I have to meet this A and B and talk to them like 5 minutes, please. Arrange me to this. Basically, this anonymous data, and it's not possible. So working with corpus data is really difficult with the respect of getting inside A and B's motivations for certain moves in a dialogue. So you have only this dialogue. If you are bored in the Saturday afternoon, I really recommend to read British National Corpus or any corpus that is available online. It's a lot of fun. I don't recommend reading this B corpus about electronics because, yeah, if you have troubles with sleep, maybe. But yeah, let us go back to this question. So what we have to do, there is no other way of analyzing this data, is to try to introduce some anti-mimetic premise to this dialogue. We'll never be able to meet B and ask B in this data, is it true what I made it on blue? But if you consider the dialogue as it follows, it seems reasonable to assume that B, in his head, assumes that I want to push it around if and only if it is disturbing you. That's why I'll ask you this question. So yeah, that's the one weak point of this argumentation, because if you work with corpus data, there is no other way of doing it. I mean, to some extent, of course. So if you will agree that we introduce this anti-mimetic premise, we can go further. Do you agree? Silent. Oh, there is one. Okay, we can go. Okay, I had no backup plans, so thank you. Okay, so A's question might be, in this context, interpreted as an expression of a problem issue to solve. And after the announcement of the question, do you want me to push it around? It becomes a problem to be solved by B. So I ask question, and I push this question to you, exactly as with my question from 2 seconds before. Shall I continue? And now it's your problem, not mine. And then you take it back. And this question becomes B's initial question that has to be processed. And B process this question on the basis of this anti-mimetic premise. So we would like to say, was this reaction rational from B's perspective, from the perspective of the dialogue? And if we focus on the B side, because now we are on the B side in this dialogue, it has to react, process the question A asked on the basis of data he has. So we can represent it in our formal language, which is simplified to some extent. So is it the case that P will represent B's initial question introduced into dialogue by A? So do I want to push it around? P, if and only if Q represents the piece of information used by B to decompose this initial question. This is the anti-mimetic premise I've introduced, and you agreed with N1. And after the initial question is processed, B comes to a question, is it the case that Q, which is it really disturbing you? Which is later publicly announced and asked to A, and now it's A's turn to react. So was it a rational step for B in this dialogue to react with this question? Yes, it was, because you can reconstruct the process which leads to this, And from the normative point of view, it was well motivated because we know that erotetic implication holds between this question and this question on the basis of this assumed premise. So it was well motivated because two requirements of erotetic implication holds. And if you think about solving the initial problem, which is should we move it or not, we are getting closer to the solution. Thanks to this. So the motivation behind this dialogue move is explained by the erotetic implication. Of course, probably if you would ask B, do you know the notion of erotetic implication? It will not be true, but this is our interpretation of the move from the outside. In the same manner, we can also interpret different examples from B and C, like this one. Of course, in many cases, we have to introduce this additional anti-mimetic premise, and then use erotetic implications to present, to show, to argument that it was reasonable or well justified to use this reaction here. Like in this example also, you see that those anti-mimetic premises have different logical connectives used. I'm sorry, I'm skipping this because I want to show you a better example. Because up to this point, you can say, okay, it's quite nice that you have some data from British National Corpus, real life dialogues, and you can present that presumably after you assume certain anti-mimetic premise, the erotetic implication is preserved. So the query response is well justified. But can you show us the example where you do not assume any anti-mimetic premises? And luckily, yes, but it's way much harder to find. But we have some examples like this one. This is from this B corpus. So there are some examples where premises are revealed by dialogue participants exactly as they think they are. So this is this part of the dialogue. So tutor, this is example from the beginning of this lecture. So if they are all moving at the same speed, will anyone actually ever run into anyone else? And student asks the question, so this is query response, are they all going in the same direction? And then explains what are the declarative premises for this query response. So he states that if they are, they would not run into each other, but if they are going in all kinds of different directions, they might. So basically, if you take the logical structure of this short intercourse, so you have initial question: is it the case that P? You have facts assumed by a student, which are stated here in the dialogue. So if Q, then not P, and if not Q, then P, and the student arrives to the auxiliary question: is it the case that Q? And again, you may ask whether it was justified move. We can substitute facts with this one formula, which is equivalent, and then we can present that this erotetic implication holds. So you can justify moving from this question on the basis of this declarative premise to the auxiliary question about Q. So we may say that the question introduced by a student as a response to a tutor question was erotically implied, and thus it is well justified as a step in a dialogue. What I mean by well justified, it brings you closer to a solution to the initial question. And the advantage of this example is that those declarative premises are stated by a student. We can also find other examples where the declarative premises are clearly stated. We don't have to assume anything, but you have to distill the style or look through wider piles of dialogues. This is another example from this B corpus, which is great because it has many data. This is rather long, but we may suppress this and make a simplified version. Can you tell me how current would flow? Would it flow only through the wire or through the meter or through both or through neither? And student asks, would the leads prevent or obstruct in some way? And after this auxiliary question is resolved, this is the dependent question query response, you may see that after it's resolved, the initial question is also resolved. And again, you can make an interpretation, or you can make a formal representation. So the initial problem is expressed by this binary conjunctive question, and we know that declarative premise is represented as an equivalence, and we know that erotetic implication holds in this case. So it is justified move, and as you may see in this example, you may trace back the basic intuition behind the rationality of this move. So if you replace the initial question with the auxiliary erotically implied question, and you get the answer to your auxiliary question, you will resolve the initial one. Of course, we can also think about East scenarios. That will represent the wider parts of the dialogues. So there are some nice examples from this B corpus that you can show that tutor is using questions in order to check whether students understand something or not, and then the tutor will devise a certain questioning strategy, which might be represented as a erotetic search scenario. So this structure using erotetic implications on many levels. So up to this point, we know that the data from corpus study somehow reflects the idea from logic, namely this dependent question responses behave in the proper manner, we may say, and that erotetic implication might be used as a normative yardstick to study and models those inferences in erotetic inferences in natural language examples. And the role is that you may present that it is rational or it is well justified for a dialogue participant to replace the initial question with the erotically implied one. Of course, it's not the end. You can use erotetic search scenario to model broader parts of dialogues and focus on the interrogator's perspective. So you can use erotetic search scenarios to model questioning strategies. And one of the very fruitful ideas is to use it to model the so-called hidden agenda. So you can easily imagine that you have your initial question, which you cannot reveal, as you are a teacher, and you want to check whether a student understands inferential erotic logic. So if I would ask you, do you truly understand inferential erotic logic now? So what I get is your declaration. Yes, I understand. No, I don't understand. So it would be reasonable for me to hide this question from you, decompose it, and ask a series of auxiliary questions which are related to the initial one. So for example, I may ask you, can you give me the definition of erotetic implication? Or can you explain me how a question is modeled in IEL? And then, using answers to this auxiliary question, I can get my answer to my initial question. It's very popular in teaching. So we did this for many different, not for many, but for different different fields, like Turing test. You can model Turing test with this. You can model deductive puzzles. You can model tutorials, for example. What you can make more, as I said, IEL has this nice feature that it is not attached to any declarative logic. Using minimal erotetic semantics, you can take any basic logic, providing some conditions. So, for example, if you take three-valued logic and you provide ternary questions that you have three possible answers, yes, no, and I don't know, so you can devise erotetic search scenario which is a questioning strategy with gaps. So what to do if a student says, I don't answer your question, or I don't know. So then you can model these situations, what to do when you obtain such an answer. What is more, you can add a dynamic picture to this whole scheme, because now it's all very static, if you think about introducing this scenario. But if you use formal dialogue systems, like introduced here, you can describe how a scenario changes accordingly to what's happening in a dialogue. And you can use it, for example, to describe questioning-related behaviors in the context of tutorial dialogues. So what will change when you go through a dialogue according to according to Erotetic search scenario? What is really nice, if you think about the argumentation I've made, it's always a good test for your model, not only to check whether it's not only a good model to describe stuff, but if it allows you to generate stuff. So what we did, we asked ourselves whether we can generate question responses on the basis of Erotetic search scenario. And it's possible. You can download a prologue implementation of the procedure which uses Erotetic search scenario, and on the basis of this scenario generates question responses of the form type. So you can have an interaction. You can ask. This is described. So you can ask a question, and the system will generate a question response on the basis of each scenario it has on the database. And I'm going to the end. So what is more and even more fun, as I said, working with corpora is very tiring and ungrateful, because you cannot find those guys behind the data. So you can use IEL and the ideas I've presented as a normative framework for designing empirical research, if you are interested in the erotetic reasoning. So we got, for example, a good psychometric tool called Erotetic Reasoning Test. We have an online game for collecting data. This online game is a detective game that people play online to solve detective puzzles, so they have fun. And we have the data, and we can ask those guys, fortunately, about some explanations. And the mind maze is is also this is a popular card game modified to collect data about erotetic reasonings. If you are interested in the data, we've gathered all the data we have in the erotetic reasoning corpus, which is a corpus of the question processing data inspired by the work I've presented, and those tools I've introduced here. It's available here. It is what is really nice. It is a proper corpus, so you have 3 layers of annotation: pragmatical one, structural one, and the most important one, inferential one. So you will find information about erotetic inferences inside the corpus. All the data is in Polish, but it's not a problem because the all tagging is in English, so you can use it. There are some tools to browse it easily. Thank you. Oh, and of course, I hope that this whole trip to the wild will not end up as this. So many children try to hop on a not real horse and try to go to the woods with this.
Well, thank you for your talk. Now I'm really quite afraid to use the term, but do you have any question?
Actually, don't think that I need that one. Well, I can use it. So yeah, my worry is that actually about methodology, kind of from philosophical side of that thing. It seems that when we have questions, especially natural language, we as well have those so-called opaque contexts, or things when people think, people believe, people know things, right? And in those things, well, strange things happen. For example, a good example is with the scheme, is it P, if P then Q, and if Q then P, and is it Q, right? Something like that happened here. My example would be with lions. So are there lions? If there are lions, these are not fake tigers, right? But as we know from epistemology, it doesn't so quickly follow that if I know that there are lions, they are not fake tigers, right? So, but it seems that in this context, when some person believes, and you spoke about justification, if I understood that correctly, that those implications are not that simple. Another example would be opaque context in Aquinian sense. So, for example, we have something like, well, Jack or whatever believes that there are spies. So if he believes that there are spies, so he has on one hand sentence or question, are there spies? To which he would answer positively. But then from that, if there are spies, it follows that there is at least one person which is spy. So the Jack doesn't know whether there in fact are any spy. He doesn't know them in person. So he must conclude that he, after all, doesn't know that there are spies if he can't show one. So those cases could arise, I think, in those kinds of reasoning. So do you acknowledge them, or they are unimportant?
Yeah, of course they're important, but one thing we should remember here is that those logical structures I've presented to you, it's only an interpretation. So as with logic usually, you can take a inference scheme and use it for different purposes. So the argumentation about justification, so the justification is not a logical one, but when I say that the dialogue move is justified or reasonable, it's reasonable from the perspective of the goal of a dialogue. So my claim is that it is a reasonable dialogue step if it brings you closer to the solution to the initial problem in a dialogue. So that's why I claim that erotetic implication is a good tool of modeling such behavior. I am really certain that if you would ask a participant in one of our studies, do you use erotetic implication daily, on a daily basis? They will say no, because I don't know what it is. But they might use it. It's like with rationality of decisions. So we have the theory of rational decisions in economy. But yeah, we don't do this. But it would be good to do this.
So, for example, we could have this dialogue. Well, for example, you ask the person, are there lions? And the person says, yeah, I think so. And then would say, but are you sure that they're not fake tigers? And he says, well, I'm not so sure about that. And you could say, well, then probably you don't know that they're lions. So you could use then erotic reasoning to confuse a person rather than explain. Isn't it right? Kind of.
I don't think so. Okay. I don't see how you can relate this.
Oh, okay. Yeah. Well, thank you.
Okay.
We should discuss this.
So I just thought maybe they are better.
My name is Andrius Kulikauskas from Vilnius Gediminas Technical University in Lithuania. And I'm interested in the idea of questions, answering questions. Partly tomorrow I'll be speaking about games, and the idea is that you create a world with a game, you enter with a question, and then you play until you come up with an answer, that everyone agrees on. So, but there's ways of having a game within a game, and so one of the ways is you can, like you're saying, you can have a question within a question. But the questions that seem natural here would be questions that kind of take you a bit out of the game. So like in the activities that you have, maybe they may be a little bit artificial, or they're tutorial. So they kind of have this world like that there's a certain amount of knowledge, and if you just kind of dig deeper, you will focus into the knowledge that you want. But I think a lot of questions in life are kind of existential, where you have to completely doubt everything you know. So an example would be like, how do I know I'm not a robot? It's a difficult question because, if you are a robot, then you have to doubt everything you know. But the answer is the question, would it make any difference? So you tell me what a robot is, and then I'll be able to check. Maybe robots don't, bleed or whatever. I can check, or maybe it doesn't make a difference. You can call me a robot, it doesn't matter. But this kind of counter question to the doubt allows you to not have to rely on your own data, but it helps to create the relevant data. So I'm trying to claim that there's basically 6 counter questions like that. Like, how does it seem? Like, do I truly like this? And maybe my question is, I'm curious if it creeps up in some of the things you do. Like, for example, do I truly like this? There was a question like, well, how does it seem to me? Do I truly need this? What else should I be doing? Is this truly real? Would it make any difference? Is this truly problematic? What do I have control over? is this truly reasonable? Am I able to consider the question? Is this truly wrong? Is this the way things should be? Like those seem to be very natural, and I can show how they're systematized, etc. But do anything like that come up in your corpus or not?
So that will be a comment for the first question and the second question. So our way of thinking was from the data to the typology. So we do not claim that the typology is full, I mean complete in any sense. So there are probably some question answers that we don't met in this data. So it might be, as you said, that there are some examples that are not that will not fit in this schema. And what I said at the beginning, so this is quite crucial for this work, that we focus on this narrow class of dialogues, namely goal-directed ones, because dependent questions are the most popular there. So we can claim about this rational dialogue moves in this context. We meet the dependent questions in the general corpus, like B and C, for example, but then much more happens there. So it might be the case as you said. So there might be some cases that we'll not be able to explain with this approach.
Okay. Thanks. I have a question on your use of the notion model. You've been using that a couple of times. At the same time, you've been very careful to say, you've also repeated a couple of times that you don't suppose that people, that the actual cognitive processes of people are along the lines of the rules of the logic, right?
So not in the simplistic way.
Well, that's the question. So if you then say that the logic allows you to model certain dialogues or kinds of question pairs, what exactly is it that you are modeling? What aspects of it? And so let me give you a clue that I was thinking of, and I'd like to have your comment on. I was reminded of Mars' levels of distinctions, levels of explanation in cognitive science in general, cognitive sciences in cognitive explanations in general, and I was wondering how your use of logic and your use of the term modeling relates to those levels.
So yeah, it's very simplistic way of using the term of model. The way that the reason behind me refraining from saying that we are using logic in our heads is because of the methodology I use. So I use the model in the sense that it allows you to formally describe the phenomenon and to generate the phenomenon. So that's the way.
Would it correspond to Mars' first level, the computational, the abstract level, and leave it a completely independent enterprise or partly independent enterprise to investigate the algorithmic level?
Yeah, I think so.
Okay.
If I may comment on that, well, it's a very good question, mostly because I will be more brave perhaps, I would say that we do use logic to some extent, to some reasonable extent. But it seems to me that, yes, this is addressing the computational level, and that this reframing was motivated by the fact that this computational level can be modeled in different ways. The very same data can be modeled in very different ways. But what we assume is that the algorithm is more or less the same. It's only, well, differently shaped, as it were. So these are different computations, but of the kind of the very same process. And in this sense, I would say that yes, there is a logic involved there, and to some extent, these models can be judged or evaluated as being more or less adequate to what people really do.
I would tend to disagree. Precisely. Maybe it's just a matter of terminology still. So the way I understand Mars distinctions is that you can have different algorithms computing the same mathematical function. One of the reasons why I like that from a linguistic point of view, that distinction, is that people can reach the same kind of communicative understanding, but their internal processes for getting there to the understanding may be different. Their knowledge basis may be different, and the processes, their linguistic experience may be somewhat different, making their internal cognitive processes not necessarily identical, even though their meanings are, in the end, given their understanding, the visual understandings are identical. So you need to, therefore, and Mars levels give you precisely a nice kind of conceptual distinction to say, so therefore, given this differentiation, we need theories, both sophisticated theories, both for the proper characterization of what it is that mutual understanding consists of, and what independently but mutually constraining each other of the processes by which each individual computes that meaning and that understanding. We should talk about
Yeah, it's a longer discussion. I mean, this is not a coincidence that we started with the corpus data, and then we've tried to move this further. So we don't have clear answers also at this point.